Hi there, welcome to a complete tutorial on machine learning plus agentic AI. And here I'm going to show you a project which is using Python and LangGraph. And here are the learning objectives. First of all, you will see on how to use machine learning to make predictions. You will then see on how to use agentic AI for automation. You'll also see on how to integrate machine learning models with AI agents. And the complete solution is also available on GitHub. Now, if you are already aware of machine learning, you can directly skip to the agentic AI part. Now, before I go into the code, let me first show the use case. So the use case is around customer retention in a telecommunication company. So we are going to use machine learning to identify which customers are likely to leave, also called a churn or churn prediction. And then we are going to use agentic AI, which is going to send customized emails to all the customers who are predicted to leave and with an objective to retain those customers. So these emails are not generic emails, but they take into account the predicted reasons why the customer is going to leave. Now let us look at the solution before we go into the code. So the solution has got two parts. First is machine learning and second is LangGraph agents. So machine learning, we are going to start with some data which is related to telecommunication company. We go on load the data, then we are going to also clean some data. As usual, no data is clean, so we need to clean it. We have to do some feature engineering, which is going to help us improve the model accuracy. We also need to do some pre-processing, train our model. We also have to do some model explainability because we want to find the reasons why the customers are going to leave. And then we are going to save this model. Now, in the second part, we are going to take this model and it will be passed to LangGraph. And we are going to create some objects such as state variable, which is going to receive this machine learning model. And then we are going to create a graph, which is going to do all the steps of prediction, identify churners. If there are any churners identified, it is going to find the reasons for churning. It is going to also create a draft emails. And for this, we are going to use GPT-4 large language model. This will be then output and then the graph is going to end. If there are no churners identified, then we kind of just end the graph. So let us now start with the code, and first step is to import some packages. So the packages are mostly around scikit-learn, which is going to help us build the machine learning model. Let us also now look at the data. So the data is coming from a telecommunication company, so it has got fields like customer ID, gender, senior citizen, as well as it has also got different fields which are related to the different services which this customer has, as well as it also has got the billing information, as well as you also have this indicator called as churn. It means has the customer left or not. So for example, 0 indicates the customer has not left and 1 indicates the customer has left. So this is a historical data, and we are going to use this historical data to train our machine learning model, which can then predict on any new data. So here we also can see that in the training data, we have a churn rate of almost about 26.5%. It means that there are less churners compared to the customers who are already with the company. So this ratio is a bit low, and this is also called as an imbalanced data set. And you will see on how this information is going to be useful in the steps of machine learning. Now here is also a summary of the different fields. So you can see that for each field you have a type. For example, object means it is a non-numerical field, and if it is integer or float, which means that this field is a numerical field. Now let's go to the next step, which is of cleaning the data, and there are two issues to fix here. So first of all, in the data I've seen that the total charges have got some 0 values. So for example, these values are indicated as NaN. Generally speaking, for a telecommunication company, there are no customers with 0 charges. So this is an outlier, we need to clean it. And of course, customer ID itself is a unique identifier which has got no predictive value, so we can drop it. So here we can use a function called as fill NA, and this is going to take all the values which doesn't have any total charges, and we are going to replace it by a median value. And here the DF is our data frame in which we have read the data. And then we can also drop the column called as customer ID. Now let's go to the next step, which is of feature engineering, which can help us improve the machine learning model accuracy. So there are two features over here we are going to create. So first is a tenure group. So tenure is number of months a customer is with the company, and this is a continuous number, but we can create groups, or also called as bins. So for example, we can create groups such as 0 to 12 months, 12 to 24 months, so on and so forth. And you can use this function called as pdcut, which is going to make this happen. And then we can also create a new column called as charge ratio, which is total charges divided by tenure. So you'll see after this feature engineering, you will see these new columns which have come, like a tenure group. For example, if a customer is 1 month, then this customer will fall in this group, 0 to 12 months. And for example, if the tenure is 34 months, in that case, this customer is going to fall between this 24 to 48 bucket. Also, you have this charge ratio, which is basically the total charges divided by the tenure. Now let us go to the next step, which is to do a splitting of features. It means we have to identify what is our target. In our case, this is John. So this is, we put it in this variable called as Y, and all other columns are in X. We can also identify what are the numerical columns. So we can use this function called as select D types, and it includes, if it includes integer or float, it means that this is a numerical column. And if the type is an object, in that case, it is a categorical column. So here you can see that fields like tenure, monthly charges, total charges are numerical columns. And then fields like gender, phone service, for example, is a categorical feature. And the reason why we are doing this is because we have to apply some pre-processing. So for all the numerical values, we need to apply a standard scaler. So all the columns, all the numerical columns, they are in different scale. For example, if you see tenure is in months, and total charges, monthly charges, they are in dollars. So we need to convert them into a constant scale, and this you can do it using this function called a standard scaler. And for all the non-numerical or categorical columns, we need to also convert it into a numerical value using this function called as one-hot encoder. Now the next step is to take the data and split it into two, train and test. It means that we are going to train our model based on the training data set, and then we are going to test our model based on the test data set. And here we are taking a 20% ratio. It means that of the data, we are going to take 20% of the data to test, and 80% will be the data for training. So here you can see the total number of records in the training data set is almost about 5,625, and the test size is 1,407. Now we are all set to train our model. So we are going to use different models like logistic regression, random forest, and gradient boosting. So these are very popular machine learning algorithms. And we are going to loop through each one of them, and we are going to create a machine learning pipeline. So this pipeline has got the preprocessor. So if you remember, the preprocessor is basically all the pre-processing steps such as standard scaler, one-hot encoder. Right? So we take this preprocessor, and then we also pass in the model, which is one of these models over here. We then apply this fit function, which is training our machine learning model, and then we are going to use that model to make the prediction. Now, if you remember, in this particular data set which we have taken, we already know, right? We already know if the customer has joined or not. So this information, we are going to also compare it with the predicted value. And this is going to help us to compare between the predicted value and the actual value what we have, which is going to help us give us some accuracy scores. So for example, here you see for all the different models, logistic regression, random forest, gradient boosting, you have some accuracy measures. Now, if you remember, I said earlier that this is an imbalanced data set. It means that the churn ratio to non-churn is almost 26%, which is quite low. Now, if you have an imbalanced data set like this, in that case, the accuracy measure, which is important, is the F1 score. So, for example, here you can see that we have an F1 score of almost about 88% to identify the non-churners and 60% to identify the churners. So, this is a good score, and you can see that the best performing model here seems to be this gradient boosting model, because this has received an highest overall score, which is also called as this AUC score. Now you can also compare all the models in a visual way. So here we have our 3 models, and here this is the AUC score, and you can see that the gradient boosting is one of the most top performing models. So we can also see some confusion metrics, which is also a way to measure the accuracy. So for example, here we have almost about 1034 customers who have not churned, and out of that we correctly identified 946, but we incorrectly predicted 88 customers to be churning, even though they were non-churners. And then we have 373 customers who have churned. Out of that, we identified 196 correctly. However, we didn't identify 177 customers. We incorrectly predicted them that they are not going to churn. So this is a confusion matrix, is a nice way also to visualize the accuracy of our model. Now comes an important step, which is to find out why the customers are leaving, because we are going to need this to draft these emails later on. And this you can do it using algorithm called as SHAP. So what you do is basically you take the best performing model, and then there is this algorithm called as SHAP tree explainer, which is going to find out the reasons why the customers are churning. And you can make a visualization like this. So in this visualization, you see some dots on the left hand side and on the right hand side. So if you see all the dots on the right hand side, it means that these data points are not contributing to churn. But if you see the dots on the right hand side, it means that these dots, these data points, are contributing to churn. And then you also see 2 values, the blue value and the red value. So blue value indicates low value and red value indicates high value. So if you take this row called as tenure, right, and you see blue values on the right hand side, it means that low tenure, if some customer is just few months with the company, there is a very high probability that this customer is going to churn. So this is a nice way to understand what are the reasons why customers are churning. And then you can also visualize the top factors which are leading for customer to leave the company. For example, month-to-month contract, which is short-term contract, and tenure are the top reasons why the customers would leave. Now you can also save all this information into a pickle file. So you are going to save the model, the best model, into a pickle file, along with you are going to save the information on the numerical columns and categorical columns, and all this information is going to be saved in a file called as .pkl or pickle file, and we are going to use this information in the next part, in the next phase, which is of identifying all the churners and then creating specific emails using LangGraph agents. So now let's move to the second part. Okay, so now let's move to the next part, which is creating a LangGraph agent to create all these retention emails. So LangGraph is an agentic AI framework, and let me give you a quick overview of it. So LangGraph has basically 2 kind of objects, important ones. You have a state object, which is going to store all the variables like data, the machine learning pipeline. So this machine learning pipeline is coming from the machine learning model what we have created earlier, predictions, churners, reasons why customers are going to leave, emails, as well as status. And then it has got a graph object, which is basically a connection of different steps. And all these steps are also called as nodes. So we start with predicting which customers are going to leave. We identify those customers, and then we are going to find the reasons why these customers are going to leave. And we are going to take these reasons, and then we are going to send it to a GPT-4 large language model, which is going to create these retention emails, and then these emails will be saved and the graph is going to end. If no customer is identified to leave, we're simply gonna end the graph. Now let us start by importing some packages. So here, the important package is the LangGraph package. We also have to set an OpenAI key because we are going to use the large language model from OpenAI, which is the GPT-4. And here we are making some configurations, for example, model path, as well as the data path, as well as we are also setting a churn threshold of 55%, which means that if a customer is predicted to churn with more than 55% probability, then only we are going to create all these retention emails. I'm also taking just the top 5 features to send to the large language model to create these retention emails, and for demo purposes, I'm just taking a few records. Now, let us create this agent state, which is basically a object with a dictionary, which has got all these different keys such as data, pipeline, metadata, prediction, churners, and then all this state is going to be filled up later on. Now, we also have to create all the helper functions. It means that all the data preparation steps, what we have done earlier, we also have to apply for any new data for which we want to make predictions. So, for example, removing the not applicable values in total charges, creating the groups from tenure, as well as creating this charge ratio. Now, in LangGraph, every step is also called as a node. So we are going to create all these nodes. So the predict node is going to take the model from the state variable. It is going to take the data. It is then also going to drop the customer ID and churn, and then it is going to make the prediction if the customer is going to churn or not. And then these predictions are passed again back to the state variable. So this is very important. And just to give you a look on how this looks like, so between the graph and between the state variables, you'll always have to communicate. All the results of all these steps have to be stored in the state variable so that the following steps can use it. So this storing in the state variables happens when you pass a return like this, return state, and then you pass the predictions into this prediction key. So your state variable will be updated. Next node is to identify churners. So we are going to identify churners for those who have a probability of more than 55%, which is stored in this churn threshold. Once again, we are passing the churners as a state variable so that it gets updated in the state. Node 3 is about finding the reasons why a customer is going to churn. So we are going to use this function, which I've explained to you earlier, which is this SHAP.tree explainer, which is going to give us all the reasons why the customer is going to churn. Now we are all set to create all these draft emails. So here we take all the reasons why a customer is going to churn, and then we are creating this prompt. So this prompt says that you are a customer retention specialist. This is the customer profile. These are the reasons why a customer is likely to churn. And then we are asking the large language model to create an email which is warm, which opens with empathy, and then once you pass this prompt to this function called as chat completion create, you give the model also GPT-4 mini, it is going to then give us back the draft email, which again we pass it to the state variable. Now we can go through these emails and then we can store it in the output, which is basically a JSON file. And then we are done with creating the nodes. Now we have to create all the links between the nodes. This is also called as a route. Now there are classic traditional routes, but there is also conditional route. And for example, we have to create a conditional route between the identification of a churn and the next step. If no customers identify, in that case, we simply have to end the graph. But if there are customers who identify to churn, in that case, we have to continue with all the steps. So this is a conditional edge or conditional route, and we are going to add this route in the graph what we are going to build here, which is starts from this step. So here we are building a graph. Basically, we are building the complete picture which I have shown you here. This is what we are going to build over here. So we already have created all this function. We have created this node. Now we are going to create this graph, which means that we are going to connect all the different nodes. And this is called as creation of graph in LangGraph. So how does this happen is pretty simple. You start with a state graph variable. So this is your graph, and then you simply add nodes. You add node for predict, identify churners, explain SHAP, draft emails, output. These are all the functions what we have created earlier. You set an entry point to predict. You also add a classic, a traditional, a simple edge between predict and identify churners. But between identify churners and the next step, which is to explain the reasons, is just a conditional edge. It means that only if there are churners, then it is going to go to the next step of identifying the reasons as well as creating these emails. But otherwise, it's just going to end. And this conditional edge, if you remember, is coming from our previous definition, what we have created here. Now, once we have identified the reasons, the next is to draft emails. So this is a simple edge. Between draft emails and output is a simple edge, and between output and end is also a simple edge. You can then compile the graph and you will see a visualization like this. So it starts with prediction, identifying churners. If no churners are found, then the graph is going to end. So this is the conditional edge. If churners are found, then we are going to apply the reasons for churning. We are going to create these draft emails by sending the prompt to the large language models, and then we are going to save the output. Now we are all set to execute this graph. So we need to load the model, what we have created earlier. And then we can also read the data and we can run the agent. So running the agent is simply using this app.invoke function. We just execute the graph, and then it is going to create all this draft email. So for example, if I take this customer which has got a churn probability of 55.7%, which is more than 55%. So, and it is going to create a draft email, and here you can see that this is identified. The top reason to churn is this month-to-month contract. So the email says that we understand that as you are on a one-to-one contract, you might feel a bit uncertain, but we are going to offer you 10% discount on next month's bill. So this is a nice way to identify who is going to churn, the reasons, and then propose a solution also to retain these customers. So all these emails are going to be saved in a JSON file. And then you can also have an analysis of the top churners, as well as you can also see the emails which have been created for each of these churners. So this was a complete tutorial of how to use machine learning to predict churners, and then how to use LangGraph agents to create an automation which is going to take all the machine learning models and going to take some actions like drafting emails, which is also then connected to the large language model. So hopefully you have enjoyed this video. I've also left a link to the complete code on my GitHub, and this link you can find in the description of this video. And I would also like you to give a comment, give your feedback on how comfortable are you with machine learning and LangGraph, and if you have some special topics for which you want more tutorial, just let me know. So thank you for watching. Enjoy, keep learning, and please subscribe to the channel. Thank you. Bye.